students, welcome back to the series of lectures of Intermediate 1B. Today I am going to discuss with you the last exercise of differentiation chapter, that is the 9D exercise. In that, the first problem I had noted down. The before exercises which we have come across the differentiation chapter, all the exercise problems and the introductory part, they are in the channel playlist. Yes, you can check them out. And the immediate previous video lesson of this chapter, the before previous exercise, that is 9C, the last problems, you can check it on the I button. Okay. Here also the links will be placed in the description below. Right. The first sum of the exercise 9D is if y function is equal to 2x plus 3 by 4x plus 5, then find y double dash. That means here they are asking us to find the second derivative of the y function. So there are two dashes here, that means second derivative. Right. So how do we proceed? First we usually do the first derivative, then after getting the answer, for that you need to do again derivative. That is nothing but the second derivative. So we will differentiate with respect to x first. Differentiating with respect to x, so that we get y dash. Okay, y dash we write it. Differentiate dy by dx. We represented dy by dx as y dash. Okay, here this function is in the form of u over v, right? Quotient rule. So let us apply u over v. So u over v dash. So let me write once here. V into u dash minus u into v dash upon v square. Okay, so this is the rule, quotient rule. Okay, so likewise, so 4x plus 5, this is our v function. Differentiation of u is just 2. Okay, and minus u value as it is I write, and differentiation of v function, just differentiation of v is 4x is just 4, and for the constant it is 0 over v square, so 4x plus 5 whole square. Right, this again we will do, this becomes 8x plus, let's open the bracket, plus 10 minus 8x here negative 12. Okay, over 4x plus 5 whole square. So this can be simplified. So this is first derivative. Okay, 8x goes off, 10 minus, so that is minus 2 upon 4x plus 5 whole square. This is the first derivative, y dash. Now we have to find the second derivative. So for this only we will be differentiating with respect to x. That comes to y double derivative. We don't call double derivative, but we call it as a second derivative of y function. So again this is under root, so this is again in the form of we can also tell this as you can take this as constant. Yes, can take it out, and 1 upon this we can take. So derivative of this. Yes. So here only 1 I am writing because this is already derivative. For that again one more derivative we have to do. So this comes to minus 2, you can take it out, and here derivative of 1 upon this. So 1 by x, so that is x raised to the power of minus. So this comes before, so minus 2 4x plus 5 minus 2 minus 1. Okay. Again, according to the chain rule, we should do the differentiation of 4x plus 5. Differentiation of 4x plus 5 is just 4. Yes. So this becomes, just open the bracket, minus 2 plus 4 into 4, that is 16. 16 upon, we can write this below, 4x plus 5 whole cube. This is minus 3. So if it comes down, it becomes plus 3. So this is the double, this is the second derivative. Likewise, pause it and note it down. Let's see the next one. Second one, y equal to ae raised to the power of nx plus be raised to the power of minus nx. Then prove that y double derivative, that is the second derivative of y, is equal to n square y. So given we have to prove this, say starting with this. So first derivative we will find out the differentiating the first one, that is y dash. Okay, y dash, let us do this e. So a is a constant, we can take it out, and e function, the derivative of e function, e raised to the power of x is e function only, e raised to the power of nx. But according to the chain rule, this is not x, this is nx. So again I should do derivative of nx. Nx is just n. Okay, plus the same way here, b is a constant, it comes out e raised to the power of minus nx is e raised to the power of minus nx only. Again if you differentiate minus nx according to chain rule, minus n comes out. Okay, minus n. So derivative of x is just dx by dx is 1. So this becomes ae. So n, you can write here n ae nx. So negative is there, minus nb e raised to the power of nx. Right. So this is our first derivative. So we want the second derivative. So let us differentiate again. Differentiate again with respect to x. So that comes to y double. So y second derivative is equal to n and a, I can take it out. Again, n is a constant, a is a constant. So n a I can take out. So ex is e nx. Again for chain rule, nx means n. Negative is there. nb I can take out. E raised to the power of nx, derivative is e raised to the power of nx. Again chain rule, minus n. So this becomes n. So n into n square ae nx minus minus plus n square be minus nx. So here common thing is n square. Okay. So if you are taking n square out, ae nx, right, plus be raised to the power of minus nx. So this part is nothing but the y. So this is n square y simply. What is this actually? The double derivative, the second derivative. So we have proved. Hence, thus proved. Okay. So note it down. Here, the second section in that, find the second order derivatives of the following functions. In that the first bit, cos cube of x. This is the function f of x. So we have to find the second order derivative. Okay. So here if you are seeing this is cos cube x. First we will transform this trigonometric ratio into our known one. Okay. Cube is involved here in what if you are taking cos 3 theta. Cos 3 theta, in that formula cubes are involved. Okay. So that this is nothing but 4 cos cube theta minus 3 cos theta. So here cube is there, isn't it? Cube. So here we want this, bring this to this side. This becomes cos 3 theta plus 3 cos theta. Okay. So if you are bringing this to this side, it becomes plus. Here only keep cos cube theta. This 4 also you can take it out. So if you take it out, you can bring it like this. So bring this 4 to the other side. So cos cube theta, I will write it as this function. Okay, this is 1/4 of cos 3 theta plus 3 cos theta. If squares are involved, we can use cos 2 theta formula. Yes, this is the formula. From this formula we got this. Here, now we will proceed. Now we will differentiate it. First we have to find the first derivative, then the second order derivative. First differentiating this one. Let me write differentiating with respect to theta here. There is no x function here. Okay, so sorry, we have to write x only because this is 3x, this is cos 3x. The formula is in theta, but our function is in x, isn't it? So x. So differentiating with respect to x here. So 1/4 will come out. Here I'll differentiate. Derivative of cos 3x is minus. When c is involved, you get minus. Okay, minus sine 3x. And again chain rule, derivative of 3x is just 3 multiplied by 3 plus 3 you can take it out. and cos x is minus sin x. So this equals to 1/4. You can write here minus 3 sin 3x, okay, minus 3 sin x. This is only the first derivative. This is only f dash of x, okay. If the function is in fx given, right, this is fx, so f dash x. I will do the second derivative. So differentiating with respect to x again. So that comes to 1/4. Take the constant out here. Minus 3 also I can take it out. Sin x, differentiation of sin x is just cos 3x. Again with the chain rule, if you differentiate 3x, you get 3 multiplied by 3. Here negative sign is minus 3, can take it out. Differentiation of sin x is just cos x. Okay. Right, sin x is cos x, okay, only positive cos x, right. We can write this here 1/4, here minus 3 cos 3x. So see here, this is minus 3 minus 3 minus 9, but here if you see in both these terms, minus 3 I can take it out, okay. So let me take minus 3 out. So this becomes minus 3/4. So here what does remain? One more 3 is there, 3 cos 3x plus, because we have taken out minus 3, just cos x. So this is the second derivative, second order derivative. Pause it and note it down. Here the second bit, y equal to sine raised to the power of 4x. We have to find the second order derivative. Here first, before doing the derivation here, differentiation, we will simplify this. We don't have any 4 theta formulas, okay. Sine 2 theta, sine 3 theta we have. Just so here what we will do, we can write this as sine square x whole square, okay. So again sine square, we can use the formula of sine 2 theta, sine 2x, okay. That means 1 minus cos 2x upon 2. Sine square x is 1 minus cos 2x upon 2. Again there is a square here, right. This I can write it as 1 minus cos 2x whole square. I can write 4 outside. 2 square is 4. We can write 4 outside. Now we will still simplify this. That comes to 1/4. Okay. So a minus b whole square formula, we will expand a square plus b square, okay, minus 2a and b. So 2 cos 2x. A square, b square. So b square, b is already 2x. So square is cos square 2x, okay, minus 2ab. A is 1, b is cos 2x, right. Here we got this. Again we have the square. If you are getting square, we will resolve it into the known formula, okay. That is the same thing. Sine 2 theta formula only we use here. We get here for cos square 2x, we can resolve it like this. 1 plus cos 4x upon 2. So cos square 2x, I can write it as 1 plus cos 4x upon 2. This as it is, minus 2x. This as it is, we will write 1/4. Still we are not doing the differentiation. We are simplifying the trigonometric ratio. Then later on we will do. Here we will take the LCM. If you take LCM, so 2 plus, this is 1 plus cos 4x. Okay, again here 4 cos 2x. So there are no squares here. If I take LCM 2, that if you take out, it becomes 1/8. Yes, I have taken the LCM and shifted to the outside. So 2 plus 1 is 3 plus cos 4x minus 4 cos 2x. Here there are no squares. So simply I can do this is y. Here I have simplified. Now I can do the first derivative. Here differentiating with respect to x. Okay, let's do this. So y dash equal to, here 1/8 is a constant, right? Now constant, 3 is constant, so 0. And what is the derivative of cos function? Cos function is minus sine 4x. Again chain rule. So 4x means 4 you get. Again negative 4. Again derivative of cos is minus sign 2x. Again derivative of 2x is 2. So finally what we get 1 by 8 here. So this becomes minus 4 sine 4x. Okay, this we will simplify. Minus minus plus 4 2's 8 plus 8 sine 2x. So this is only the first derivative. Right. Minus 4 sine x. Yes, this one, and minus into minus plus. Now we will do the second derivative to the other side here. So let me start the second derivative. Second order derivative. Y double dash, that means differentiating with respect to x. So 1 by 8 I will take the constant out. Now here differentiation of minus 4 also I can take out. Here differentiation of sine 4x is cos 4x. Again chain rule, you have to multiply with 4 plus take out 8 outside. Differentiation of sine 2x is cos 2x. Okay, again multiplying with chain rule, so you have to multiply with 2. So finally what we get, so 4 here, what 4 2's 8, 8 2 16, 4 4 16. So 16 can be come out, that is the common, and also negative sign I'll take out. So minus 16 I'll take out. Let me take out minus 16. Right. So here minus 16 if I take out, you get 4x, and if I take minus, there is one more minus and cos 2x. Right. So this we can cancel off. So that becomes y. Second order derivative is minus 2 cos 4x minus cos 2x. You can further simplify. If you don't want the minus, negative sign up, you can take it inside. Y double dash is equal to minus into minus plus, isn't it? So plus 2 cos 2x. Take this to the other, minus 2 cos 4x. So this is the second order derivative. Note it and pause. The third one, log 4x square minus 9. So this is a function where we have to find a second order derivative of this function f of x. Now here first we will simplify the function, then we will proceed. Here we can write this as log of, this is in the form of a square minus b square. So that comes a plus b into a minus b, we will resolve it. Okay. So a is 2x, a plus b I can write this, and a minus b I can write. Yes. Log of this a plus b into a minus b, that is 4x square minus 9. Again we can, the log functions, if the product means we come to the plus. Okay, log a into b is log a plus log b. Likewise, so log 2x plus 3 plus, since the product, so log of 2x minus 3. So the function f of x has resolved into two functions of log. Now we will do the derivative. We will do the first derivative. Okay, differentiating with respect to x. So we will differentiate this one. So log function differentiation is 1 upon 2x plus 3. Again we, according to the chain rule, so 2x if you differentiate, it becomes multiplied by 2 here, plus again log function 1 by 2x minus 3, again here multiplied by 2. Right. So this is only first derivative. So we will write it here. So 2 upon 2x plus 3 plus 2 upon 2x minus 3 is the f dash x. If the function is f of x, the function is f of x. Okay, it's not given y, but it is given just f of x means this is a function. So the first derivative we got. Now we will do the second derivative, f dash of x. So here can take differentiating, here differentiating with respect to x, you can write again. So that comes 2, you can take it out. Here 1 upon 2x. So if you take this function above, it becomes minus 1. So here minus 1 into 2x plus 3 minus 2. Minus 1 minus 1 minus 2 it becomes. And again chain rule, differentiation of this is just 2. Yes. Now again plus. Say, take out 2 out. So you get again differentiation minus 1. 2x minus 3 minus 2. Again differentiation of 2x minus 3 is just 2. So here what we will do, here we will multiply 2 2's 4 minus 1. So minus 4 upon 2x plus 3 square. I can write this below. Here again minus 4 upon 2 2's 4 and minus is there, 2x minus 3 whole square. So this is the second order derivative. You can also minimize it by taking minus 4 outside. If you take minus 4 outside, it becomes 1 by 2x plus 3 whole square plus, yes, this plus only, 2x minus 3 whole square. You can write like this also. If you are taking minus 4, this is the second order derivative. Okay, with this we will end the class till here. So we have done quite many problems regarding the second order derivatives today. Now we will see the remaining problems of the exercise in our next class. Hope so. Okay, thank you all.